Pause the video and read the question completely. Pressure on this mesh is given by force acting on the mesh divided by area of the mesh. Force acting on the mesh must be equal to rate of change of momentum of the water passing. Okay, so let's calculate rate of change of momentum of the water jet. It is given 50% of water doesn't get affected by the mesh. So for that 50% of water, that means m dot by 2. M dot is the actual flow rate. M dot by 2 will give you the 50% flow rate. It doesn't have any velocity change, so the velocity remains the same. So rate of change of momentum will be 0. Now there is another 25% which loses all its momentum. Okay, so 20, since it is 25%, we will take m dot by 4. Okay, and its momentum is lost completely. That means its velocity becomes 0. So initial velocity is v, final velocity is 0. So its momentum, rate of change of momentum of this 25% becomes m dot v by 4. Now it is given there is the rest 25% which bounces back. Okay, and that is m dot by 4 into v minus, v is the initial velocity, minus the final velocity. Final velocity is in the opposite direction since it is bouncing back, so minus v. So this minus minus becomes plus, so it becomes 2 m dot v by 4. So that becomes m dot v by 2. Total momentum change will become, rate of change of momentum becomes delta p1 plus delta p2 plus delta p3. So 0 plus m dot v by 4 plus m dot v by 2. 0 is for that which goes unaffected. This is for that gets stopped completely. This is for that gets bounces back. Okay, so total change of momentum becomes, rate of change of momentum becomes 3 by 4 m dot v. So the force on the mesh will be rate of change of momentum of water, that is 3 by 4 m dot v. So m dot is equal to, we know it is rho into area flow into velocity, where area is pi a square because it is flowing through a circular pipe, radius small a. So m dot is equal to rho pi a square is the area of the flow into v, velocity of flow. So force equation becomes this 3 by 4 rho pi a square v into v, that is 3 by 4 rho pi a square v square. And we know we are asked to determine pressure, right? Pressure on the mesh must be the force on the mesh by area. So 3 by 4 rho pi a square v square is the force divided by area of flow is again pi a square. So we get 3 by this pi a square gets cancelled. We get 3 by 4 rho v square. So option is D. You see, 3 by 4 rho v square. Thank you.